Welcome to the Explainer. Today we are talking about NVIDIA's next big thing, the Rubin platform. And this isn't just about making AI faster, it's about building a system that can actually, well, think.
Okay, so this quote from NVIDIA CEO Jensen Huang, it's pretty much the key to unlocking everything we're about to talk about. See, AI is moving past just giving you a quick one-off answer. Now we're asking it to tackle problems that need long chains of thought, to try things, fail, and try again. It's a real thinking process. And a brand new problem like that, well, it needs a completely new kind of machine.
So here's how we're going to break it down. First, we'll look at this new frontier for AI. Then, we're diving deep inside the Rubin platform to see what makes it tick. After that, we'll talk numbers, the absolutely wild performance gains. And finally, we'll see what this all means for the future with NVIDIA's vision of an AI factory.
All right, first up, AI's new frontier. We're talking about a shift, right? We're moving away from models that just spit back information they found. Now we need them to genuinely reason their way through really complex, multi-step problems.
You know, the name itself tells you a lot. NVIDIA named this platform after Vera Rubin. She was an amazing astronomer whose work basically proved dark matter exists, completely changing how we see the universe. It's a perfect name, right? Because this new hardware is all about unlocking the next hidden universe of what AI can do.
So, the fancy technical term for all this is agentic AI. Basically, we're talking about systems that can plan, do tasks, and reason back and forth. This isn't just about getting a faster answer. It's about getting a better, more deeply thought out answer. And to power that kind of thinking, you have to completely rethink the hardware from the ground up.
Okay, so how exactly is NVIDIA building a machine for this new age of AI? Well, the Rubin platform isn't just a new GPU. No way. It's a whole system, a supercomputer, really, built from 6 specialized chips that are all designed to work together perfectly.
So, you've got the whole shebang, a new GPU, a brand new CPU, a new NVLink switch to connect everything, a chip-to-chip link, a super fast networking card, and a data processing unit. It's the full stack. But to really get what's so revolutionary here, let's just focus on the heart of the system, that new GPU, the CPU, and the magic fabric that ties them all together.
I love this analogy. Think of it like a world-class orchestra. The new Rubin GPU, that's your powerhouse, your entire string and brass section, just delivering raw, massive horsepower for all the AI calculations. But the Vera CPU, that's the brilliant conductor. It's super power efficient, and it's custom designed to orchestrate that complex, multi-step reasoning that agent AI is all about. And for an orchestra like that to play in perfect harmony, what do you need? You need a nervous system. That's the NVLink 6 switch. And get this, to understand the crazy scale we're talking about, a full rack system has 260 terabytes per second of bandwidth. That is, and I mean this literally, more bandwidth than the entire internet. Just let that sink in for a second.
Okay, so that's the architecture. But the big question is, what does all this new tech, this insane bandwidth, actually get you? How much faster is it than the Blackwell platform, which, by the way, is already the most powerful AI system on the planet? All right, let's just look at the raw numbers. The new Rubin R100 GPU cranks out 50 petaflops of inference performance. That's its raw thinking speed. Compare that to about 9 for the current Blackwell B200. It's also using next-gen HBM4 memory. Think of that as the chip's super-fast short-term memory, which boosts capacity by 50% and almost triples the bandwidth. We're not talking about small upgrades here. These are massive generational leaps forward.
So what's the bottom line from that huge jump in specs? It's this, a 5-fold increase in raw inference speed. That means the AI models we use every single day can either run 5 times faster, or models that are 5 times more complex can run in the same amount of time. That's a game changer.
But you know, speed is only half the picture. The real revolution here is all about efficiency. That massive performance leap means you get a 10-fold reduction in the cost to generate a token, which is just the basic building block of an AI's answer. This makes the most advanced AI so much more accessible by radically lowering the cost of intelligence.
And it's not just about running the models, it's about building them in the first place. The Rubin platform is so incredibly efficient that you need 4 times fewer GPUs to train the same gigantic models. This completely changes the economics of building foundational AI. So, what happens when you put all of this together? When you combine this kind of performance with this kind of efficiency, you get a fundamental shift.
We're really not just thinking about individual servers anymore. We're thinking about entire data centers as one single giant computer.
And this is NVIDIA's vision of what they call the AI factory. A perfect example is the Vera Rubin NVL72 system. We're talking about a single liquid-cooled rack that packs in 72 GPUs and 36 CPUs, all wired together with that super fast fabric. It's not a bunch of computers anymore. It's one single supercomputer, and it's built for just one thing: to generate intelligence at a massive scale.
Look, power like this, delivered this efficiently, doesn't just make the AI we have today a little bit better, it throws the door wide open to solving entirely new kinds of problems. Which really leaves us with a huge question to think about. When the cost of complex, deep reasoning drops this much, what previously unsolvable problems are we going to tackle next? Things like drug discovery or climate modeling. The possibilities are just staggering.